Hello, this video is going to be on how to write hypotheses. And of course, the hypotheses are going to be your first step in the hypothesis testing process. Okay, so in general, when you write these hypotheses, you will always start out by writing this right here. Capital H with a little subscript O and a colon, capital H and a subscript A and a colon. Now the first statement here is called the null hypothesis. It's also referred to as the claim, and I sometimes refer to it as the model, because that statement is actually the center of your distribution of expected samples. Now it'll always have the form P equals the percent that's given in the problem. So when you read the word problem, that percent that they give you, there's definitely a percent that's given to you, and that is going to be the P that you're going to use. Now, that's intended to represent things if there's no change. Then the second statement, the alternative, right, is the alternative hypothesis, is going to have one of the three possible forms. P is greater than the percent, less than the percent, or not equal to the percent. Now, I will say that in some books, they do allow greater than or equal to, less than or equal to, but our book does not, absolutely does not. So you can't use the greater than or equal to or the less than or equal to. And then how you determine which one of these three you should use is really through keywords like higher, under, lower, different, increasing. And you want to look at the intended meaning in the problem. You have to read context. Okay? Let's take a look at some examples. So here, suppose a medical testing can detect a particular type of cancer 40% of the time. Trained dogs can also detect this particular type of cancer, and in a randomized test, trained dogs correctly identified 83 out of the 165 instances of this particular cancer. Can trained dogs detect cancer better than medical tests? All right, so here the trait is detection, whether you can detect, right, a particular type of cancer or not. And it's a yes-no trait, so that's why we're using P as a proportion or percent. And then the what we have here, the population, are the trained dogs who either can detect or cannot detect. And here you're given that 40%. That's that percent that's given. So when you start writing your hypotheses, you're going to write capital H subscript O, capital H subscript A, have your colon, and then you're going to say P equals 40%. Now I always stay in decimal form because all calculations should always be done with decimal form. And so you can write 40%, but I prefer to keep it this way so that I don't try to use the percent form. I always use the decimal form. And then, by looking at context, they want to know if dogs can detect cancer better than medical tests. So from the context, that tells me that the dogs would detect cancer more than 40% of the time. So that is my alternative hypothesis. Okay. Example 2. A chair manufactured with hardwood A can withstand a 400-pound load and buckle or break only 2% of the time. The company is considering manufacturing the same chair with a new hardwood B. In tests, the new hardwood buckled or broke 3 out of 350 times under a 400-pound load. Does this indicate that the new hardwood B is stronger? So again, the trait is whether it buckles or breaks. The yes-no trait. And then we're testing the hardwood, the new hardwood. Okay. And what we're given here is that 2% of the time, right, 2% of the time, the hardwood, when it's manufactured into a chair, will buckle or break. So how should I write these hypotheses? All right, I write the null and the alternative, and now P equals 0.02. Now we're wondering if the new hardwood is stronger. So if the new hardwood is stronger, then the percent of times that it would buckle or break should be less. So I would say, oh, well, now it's going to be less than 2% of the time that it buckles or breaks. All right? So insurance companies have determined that 4% of the general population is involved in an automobile accident each year. In a random sample of 65-year-olds and older, 4 out of 120 were involved in an automobile accident in the past year. Does this indicate that the rate of involvement in automobile accidents for people over the age of 65 is higher? So the trait is whether you're involved in an automobile accident or not, right? You either are or you're not. And then specifically, we're going to be looking at 65-year-olds and older, right? So that's my population. And what we're comparing it to is the 4%. We're just wondering, is it higher? So I would write. Now go ahead and pause the video and write the null and alternative and see what you get. So here then we'll have 4%. Now we're wondering if the automobile accident rate for people who are 65 and older is higher, so we think it might be greater than 4%. Okay. Example 4. Authorities are concerned about speeding in a residential area. If at least 20% of the people speed on Tucker Road, then speed bumps will be installed. Speeds were monitored during different times of the day and on different days of the month, so it's random. And the sample found that 920 out of the 4,000 people exceeded the speed limit on Tucker Road. Should the authorities install the speed bumps on Tucker Road or not? All right, so the trait is whether you're speeding or not. And then the population is the drivers on Tucker Road, so people on Tucker Road, right? We're driving. And what we're given is that 20% is my P, right? So when I write this, I'm going to say 20%. And now we're wondering when will they install speed bumps? Well, they'll install if at least 20%. Now, at least 20% means equal to 20% or more. But remember, we don't include the equal sign in the alternative because that's taken up by our null. So here I'll have to say strictly greater than. So it doesn't matter that the problem says at least, which really does mean equal to also. But we have to write P, the percent of people who are speeding on Tucker Road, is strictly greater than 20%. All right. Our last example. The dropout rate in Ryder High School has been 13% for the last few years. Guidance Counseling has set up a study buddy program where volunteers from the community help high school students with their studies. This year, 9 out of 90 Ryder High School students dropped out. Does this indicate that the study buddy program is working? Right? So the trait is whether a student drops out or not, right? So let's see here. So dropped out or not is the trait. It's a yes, no trait. And then the Ryder High School students, right? That's the population. And we're told that 13% has been what has been occurring for the last few years. So the null is the percent of Ryder High School students who have been dropping out is 13%. Or we're wondering now with this new program, if the program is working, what do we want the dropout rate to do? Well, if it's working, we're hoping that the dropout rate falls and it's not as high as 13%. So that's our alternative. Thank you very much for listening.